Chapter 4, Common Test Equipment. Chapter 4, Common Test Equipment. Non-resident training course, September 1998, Navy Electricity Electronic Training Series Model 16, Introduction Test Equipment. Alright, Chapter 4, Common Test Equipment. Upon completion of the chapter, you should be able to describe the proper operating procedure of the multimeter, describe the proper operating procedure of the digital multimeter, describe the proper operation procedure of the differential voltmeter, describe the proper operation transistor tester, describe the proper procedure of the resistor capacitor or RC indicator bridge, and measure resistance, capacity, and inductance. Introduction. In the previous chapter, you have learned how some of the basic miscellaneous measurement of the performance of the domain of the upkeep of the electronic system of the components you will also with the construction operating basic meter movements of the test equipment. This is what chapter will introduce some of the testing instruments commonly used with the Navy today. Multimeters. During the troubleshooting, you will often require the measure of the voltage of the current react resistance rather than the three or the more separate meters for these measurements. Can use the multimeter. The multimeter can with the circuit that allow the use the voltmeter, ammeter, or an ohmmeter. Multimeter is used often called the volt milliammeter or VOM. Once again, the disadvantage of the volt milliammeter is the external power source that is required for its operation. Therefore, no warm-up is necessary. Other advantages: portable, versatility, freedom of the calibration, error the cover, the aging tube, the line voltage variation, and so forth. Two advantages of the one with the volt multi-ammeter tends to low over the circuit under the test. Two, the multimeter movement is easily damaged as a result of improper testing procedures. Caution: never press down or place any object with a glass plate with the multimeter that can disable the meter movement from the operating properly with the cover the damage. Measuring resistance, voltage, and current with the milliammeter. In this discussion, the follower will become familiar with the operation with the multimeter with the measure of the resistance, voltage, current with the meter. Select the discussion of Simpson 260 multimeter with the shown figure 4.1. Simpson 260 is the typical voltage milliammeter used with the Navy today. Then this show of the Simpson 260X XLP volt multiammeter, milliammeter. Multimeter with a two selector switch with the switch on the lower left of the function switch with the only on the lower center of the range switch of the function which select for the tap of the current. You will be able to measure the positive DC, negative DC, or AC. The range switch is the negative 12 position switch with the select for the range of the ammeter, voltmeter, milliammeter of the branch of the will make. Milliammeter of the equipment for the pair with the test for the lead for the red is positive, the lead, the black is negative, or the common. Lead and lead. 8 jacks are located with the lower port with the lower part of the front of the panel. Prepare the meter for the U for the simply ends for the test sleeve with the power jack. Proper jack with the obtain with the circular range for the desired each of the application. The most application black lead will be in for the jack mark with the lower left with a negative sign with the word common. Alright, measuring resistance. Before proceeding, you should be aware of the following important safety precautions that must be observed while using the ammeter with the function of volt milliammeter. Caution: never connect with the ammeter to a hot energized circuit. Be sure that no power is applied and all the capacitors are discharged. The internal component of the milliamp with the very little current with the protective with the damage overload protection circuit with the view for the circuit breaker. How the damage may still with the curve with the negative with any safety precaution with cautions and instructions above. Because no external power is applied with the component with being tough with the resistance check with the logical question you may ask: what is the power with the deflection of the ammeter come from? The milliammeter contains only two battery power supply inside the case. The resistant component inside the multimeter are such of the value of the lead with the connected together. No resistance of the meter indicate the full section, full scale of the deflection. Because there are no resistance to cover the short lead with the full scale of the deflection represents zero resistance. Before making the measurement, you must ensure the ammeter of the ensure for the accurate read. This is accomplished by the short lead with it together. Adjust the ammeter adjustment and control with the point of this point directly with the zero motor marker on the ohm scale. The zero ohms control with the continuous variable to be with the adjust the meter circuit sensitivity compensate with the vary edging with the ammeter circuits. An important point with the meter, remember when you're making an accurate resistance measurement is to zero the meter with each time you select with the new range. If there's not done with the reading, you will obtain with the properly incorrectly. You will make the resistance measurement on a resistor. You make the following the consideration of the resistor being tested. The resistor must be electrically isolated. In some instances, so connection will have to be with a disconnect with the isolated resistor. Generally, isolating one side of the resistor satisfactory, you may take an accurate reading. The meter's leading must make good electrical contact with the resistor lead points of the contact should be checked with the dirt, grease, varnish, paint, and any other material with the after correcting flow. Alright, touch only the insulated portion of the test leads. Your body may have a certain amount of the resistance. Ammeter will measure for the for the uninsulated portion of the lead. Figure 4, 2 for the function for the block diagram, meter for the volt, milliammeter for the per method of checking the resistor connected with the red lead to the one end of the resistor and the back lead to the other end of the resistor. Choose of the red test lead with the multiplier function switch, and then the comparison battery black test lead. In between the battery and the function switch, you have the multiplier, but on a circuit in a parallel circuit with a meter 0 ohms. Because zero resistance coupled with the full scale of deflection, you should relive the deflection from the meter inversely proportional resistance being tested for a small resistance value with the deflection nearly full scale with the large resistance deflection will be considerably less. This means left portion of the ohms of the scale present for the high resistance for the right side of the scale present for the low resistance. Zero resistance short circuit indicates the extreme right side of the scale. Infinite resistance open circuit is located with the extreme left side of the scale. Note that you read the ohm scale with the multimeter right to left with the example with the property multimeter with the figure 4.3 with the 8 ohms. Determine the actual value of the resistor multiplied the reading of the meter of the range switch of the resistor times 1 resistor times 100 resistor times 10,000. For the 4.3 ohm meter scale, note the scale mark with the crowd with the left side of the ohm scale, which makes it difficult to read. The best range of the selected is 1 with which the point will fall in the space between the mid scale and the slightly right side of the mid scale. The division area of the scale evenly spaced provided easier reading or greater accuracy. To explain the relationship between the meter reading of the range switch setting, let's example of the of the 2400 ohm resistor, you have identified the resistor color code with the range of the resistor. One position, you connect the meter across the resistor. The meter point reflects between 200. The point labeled with the infinite symbol, extreme left side of the scale. Because resistor times 1 scale is selected with the multiple reading by 1. Obviously, the scale reading is not accurate. Therefore, you may arrange the scale switch to the next higher scale position resistor 100 to obtain more easily readable value. In resistor times 100 position, you again 0. For the meter of the time, the pointer moved the 24 mark on the scale. Because of the resistor 100 scale, the reading is multiplied by 100. That gives you more accurate reading of the 2400 ohms, 24 times 100. If you position the range of the resistor 10,000 scale accurate, which gives the more accurate reading of the time with the near mid scale with the volt ohm meter milliammeter instrument, the range of the other in such setting such for the resistor times 10 resistor times 100 resistor times negative the much easier such reading. Another thing to remember that you measure resistance of the challenge of the resistor. If the challenge of the resistor preceding example the 10%, you would exact spec the reading between the approximately 2160 to 2060-40. The reading is not within these limits. The resistor will probably change value and should be discarded. Open the resistor with a deflection within the meter. The shift the resistor call. The fail scale of the deflection right side of the lowest range scale shift the lead will shorted. Alright, measuring DC voltage. Multimeter with the operator with the DC volt, the plate with the volt, function switch for the either the two with the position DC positive, the DC negative is the C meter, leave with the cable the ohmmeter function must be connected with the proper meter, joined with the measure of the DC voltage with the red lead is the positive lead and the black lead is negative. The common lead or common lead figure A with the figure 44 with the function block diagram. The DC voltage circle the multimeter, the figure B with the Jackson switch position of the DC voltage. Or when the meter is connected with the circuit, it can become with circuit component because all the meters of the resistance they alter the circuit change with the current of the resistance presented with the voltmeter depending on the amount with the voltage being measured with the position of the function switch. Some of the multimeter 20,000 ohms per meter sensitive to measuring the DC volt 5,000 ohms per volt with sensitive to measuring AC volt with the higher more resistant with the less load. But the circuit the key with the circuit loading to an absolute minimum of the circuit under itself the unaffected by the meter in a way that you get the clear picture of the which with the circuit malfunction is not affect the meter of the circuit. Again, figure 4 with the function switch set with the positive or negative DC. That's the effect of the range of the meter of the scale of the U of the measuring DC. You have the 8 value voltage range, 0.25 volts, 2.5 volts, 10 volts, 50 volts, 250 volts, 500 volts, 1 and 1,000. Special application plugins are also available to set the range of the switch, determine the maximum value represented with a meter measuring DC voltage with the command marked on the DC last number at the extreme right side of the DC scale indicates the maximum value of the range being used with the range switch of the 2.5 position scale represents the maximum of 2.5 volts. So the relationship between the digit of the meter scale with the selecting of the range switch is always with the multiply of the full scale deflection digit of the meter of the phase with the corresponding with the number of the range switch. Example, the 250 scale with the 200 million volts of a megavolt million volt jack or 2.5 volts 250 volt range over the 50 on the scale of the 50 to 50 100 500 volt range of the 10 scale of the 10 to 100,000 volt range. Alright, for explanation purpose, let's assume you wish to measure the 30 volt with the DC within K for the select for the next higher range of the 50 volts. You play with the range switch of the 50 volt position shown to you B with the figure 4 the meter point rises slightly more than the mid scale 30 of the representative of the 30 volt DC. When you must measure the known DC with the position of the range switch, the setting will cover the approximate mid scale of the deflection reading of the take of the near the center of the scale, the most accurate of the measuring the unknown DC voltage. Is being rating with the highest voltage range until using the range switch for which working down the appropriate range of the meter node pointer move to the left, then should revert the polarity of the function of the switch. Caution: always check the polarity before connecting the meter node. Now let's discover the voltage measurement with the component with the circuit as an example. Let's measure the voltage drop with the resistor shown in figure 4 or 5. Alright, this shows your leads. We measure for the DC voltage with the drop of the component circuit with the mouse connected with the voltmeter parallel the component with the shown in figure 4 or 5. The positive red lead is connected with the positive side with the resistor. The negative black lead connected with the negative side of the voltage reading is obtained with the meter with the current flow with the resistor. Some of the voltage required with the ground with the reference point. At the end of this condition, the voltmeter is connected with the equipment ground. Other leading is connected with the test point with the voltage to be measured the polarity. Measuring AC voltage. Measuring AC voltage must set up the function with the switch AC with the same procedure that you let the DC apply with the voltage, except for the reading of the voltage AC volt scale with the polarity of the test lead with the not important motion measure with the voltage very low high frequency of the AC voltage. Should be aware of the multimeter potential interact with the VUA with figure 4-6. Functional block diagram. AC output voltage circuit with the multimeter figure B show with the jack for the switch position with measured AC voltage. Measuring output voltage when you will often measure the AC out component of the output voltage with both AC and DC voltage level exist that occurs primarily with the amplifier circuits. Multimeter of a 10th of the microfarad 400 volt blocking capacitor and serve the output jack with the capacitor block with the DC component with the current and circuit under the test but allow for the AC components to pass the indicating circuits. Caution: when the output do not attempt when using output do not attempt to use the meter in the circuit of which for the DC voltage component exceeds 400 volt rating of the block capacitor. To use the multimeter measuring the output voltage, you should follow these steps. Set the function switch with the AC plug the black test lead with the common jack for the red test lead with the output jack. Select the range and appropriate range switch with the 2.5 to 10 volts, 50 volts, and 250 volts. Currently, the test lead component being measured with the black test lead with the negative side of the component. Turn the power of the tester with the read output voltage with the appropriate AC voltage with the 2.5 range with the read value directly in the scale marked at 2.5 to 10 volt, 50 volt, 250 volt range rail scale marked AC with the red black figures immediately above the scale. Alright, measuring current. The multimeter function of the ammeter of the current flow. When you use the multimeter with the current indicating the instrument, never the connect with the lead to test directly with the voltage. Always connect with the instrument and then series with the load. To use the multimeter ammeter, use the following. Set the function of the power of the DC, assume with the correcting current to be powered with the place for the black test lead on the common jack, then the red test lead on positive jack. Set the range switch for the 1 over the 5 ampere range of the inch of the component of the physical open with the circle of the current being tested and may be measured with the connect with the voltmeter meter milliampere meter and serve the circuit using the proper polarity. Observe the making this connection. Turn on the on and reading the current with the DC scale with the same scale you measure the DC voltage. Alright, the setting the range switch to determine the maximum value with the, for example, with the DC scale. Always range the scale of the corresponding the range with the switch setting. Never determine to measure the currents greater than the setting with the range switch within the range of the shunt with necessary with the United with the marked current. When measuring under and circle with the follow the same procedure when measuring the voltage. Always start with the highest range available to work down. Use the range and give it approximately half scale of the deflection. If the procedure is full, follow the meter cannot be burned out. Figure 4 of the functional block diagram of the DC current circuits is a multimeter. Multimeter red test lead with the range switch with the shunt with the meter movement in black test lead. AC DC high voltage probe is available to use the multimeter with the probe extend with the range of the multimeter. Save the conventional man with the primary. Use the measure high voltage low power with DC with the current so sort of the shift the anode supply with the television receiver the other cathode tube circuits. Question that use the probe with electrical equipment that can deliver high power under short circuit conditions such as the large DC motor generator set with also available to high power voltage power that 10,000 volt AC power semi high voltage DC probe following exemption. The high AC voltage probe is designed primarily to send 5,000 ohm per volt milliampere. Probe is used with the volt milliampere and 10 volt AC position. You take the reading at 0 to 10 volt AC scale multiplied by 1,000 electronic digital multiplier. Electronic digital multimeter. Alright, as you study the chapter 3 of the external side of the meter, play for the meter with the circuit, the calculating energy, take for the circuit, the energy taken to depend with the sensitivity of the meter, and some gave the energy loss can be tolerated, for example, with extremely sensitive circuit, with the circuit, the oscillator, circuit, the automatic volume of the control circuit, the gradation, the normal circuit, the operation will occur. This often result of the failure to obtain the usable indication of the fault with the electronic millimeter with the practical sense of the electronic circuit with the higher impedance for the meter and the less for the loading effect for the most more accurate the measurement taken electronic multimeter with the considerable and the greater input impedance to do non-electrical millimeters. One example, the typical electronic multimeter view with the name of the electronic model 8000A digital multimeter with electronic digital multimeter that overcome the disadvantage requiring the continuous external power source for combined with the external AC source with the interchangeable rechargeable battery and other bands of the meter that can be read directly with the design, even the scale figure 4H of the multimeter, the model 8000A millimeter multimeter. Figure 4H of the digital voltmeter 8000A operating features. Your operating features, location of all of the controls, the connectors, indicators shown in figure 4A. The input terminal is located on the left side of the meter with the provided input connected to the voltage, resistance, millimeter, increment of the measurement, and with the respect to the common terminal with the radio section, readout section located with the upper half of the meter face with the containment of the emitting diode, indicate the display and measure the input with the polarity sign with the DC, measurement of the power switch with the located with the right side inside with the meter face with the push down switch. The energy of the instrument, the range switch, the located with the lower middle right hand portion of the meter face. Select the voltage to 200 millivolts, 210, 20, 200, 112, 1200. Current to 200 microamp to 200, 2000 milliamp. The resistance 200 ohms, 20, 20, 200, 2000 kiloohms. The function switch is located with the lower middle half of the left hand portion for the meter face. Select the voltage, current, the resistance of the mode. The milliamp current input terminal is also fused over the current protection of the fuse. Internal battery model power supply with the internal rechargeable batteries allow the instrument to operate at least 8 hours. The recharging battery with the complex switching the power switch of the off to connect the instrument of the AC power line. You can instrument the recharging the batteries on the AC power line with the recharging time will be extended. Overload protection. Overload condition indicates that simultaneously flashing with the display reading the DC voltage can withstand up to 1200 volt. The DC, the 1200 volt root mean squared of any range. AC voltage function can sustain 1200 volt root mean square of the 2200, 1200 volt range, 500 volt root mean square to 200 millivolt and 2 volt range. Current input fuse in particular 2 volt above 2 amperes root mean squared. Percolate resistance function 130 volt root mean squared 200 ohms to 200 kilo ohm range, and 250 volt root mean squared to 220 kilo ohms through 220 mega ohm range. Basic digital multimeter measurement figure 4 1 list for the proper function of the push button range, push button the internal input terminal connection to perform the specific measurement of the model 8000A. And there's a chart, block diagram and analysis figure, block diagram, electrical, digital, multimeter block diagram, divided the instrument in 3 major sections, signal condition, analog to digital converter, and display section. The signal condition section provided the DC analog voltage character applied into the analog divert converter section. The task is accomplished with the input voltage, direct current shown with the AC converter, active filter, associated switching. Analog digital converter section chain with the DC output voltage, signal condition section. The digital information A and D or analog to digital converter with the voltage frequency conversion technique for the DC voltage, the input of the AD of analog to digital voltage converter chain with the frequency by the analog integrated circuit with the frequency character of the magnitude polarity with the DC input of the voltage current with the output frequency with the analog IC accomplished for the digital IC or integrated circuit. Result of the continuing transfer binary format to the display section to binary number system to cover the Neets model 13 introduction number system bowling logic circuits. Display section take for the direct digital binary information for the analog to digital converter section that decodes it and visually display for the decoded digital information is displayed numerically in LED readouts. Alright, accessibility available to use the electronic digital multimeter 1 accessibility with the test lead with it shown figure 410 with the kits containing of the 2 color coded test lead with the threaded adapter. The adapter with the banana plug and pin tape with the test prod tape with the alligator clips pin binding plus slugs. Figure 4 show the higher current probe with the probe extend with the current measurement the capability with the 2 to 600 amps frequency with 400 hertz. And then show the figure 12 show the high voltage probe with the probe extend with the DC voltage range with 300 kilovolts. Figure 412 the high voltage probe. Figure 413 show the high frequency probe which allow for the measurement of the frequency range of 10 kilohertz to 500 megahertz. They show the high frequency program probe. AC and DC differential voltmeter. The differential voltmeter provides extremely accurate voltage for the measurement and is a highly reliable piece of the precision test equipment general function to compare with the unknown voltage with the known internal reference voltage to indicate the difference within each value. The different voltmeter can common use in the Navy today is the model 893A figure 414. The difference of voltmeter can be used with the conventional transistorized electric voltmeter. Differential null voltmeter can also be used to measure the variation of voltmeter voltage known as the null detector high resistance value with the megameter of the decimal millimeter measurement. Alright, your meter design characteristic. The differential voltmeter is always the instrument with the capability to make with the DC voltage measurement over the positive negative 10 microvolt, the positive negative 1100 volts, the AC voltage over the 1000 to 1100 volts, making be made with the frequency range of 5 hertz to 100 kilohertz. The measurement can be made with the load circuit with a different voltmeter, have the 4 voltage readout with the dial, the very resistance of the divider. Simon is described above. The different voltmeter UV the built with an voltmeter with a particularly unknown voltage of the makes over the compared with the unknown voltage of the definition reference the voltage supplied by the meter with the reference voltage to provide with a high voltage DC power supply dedicated resistor divider assemble the string with the set with the voltage reading siding dial the way with the option of the high voltage power with the supply can be precisely divided increments such for the 10 microvolt of the reading readout with dials or even the jump of the meter points at 0 to unknown voltage red with the voltage dials. Our primary feature is a differential voltmeter that does not draw the current by the unknown source of the DC measurement. The measurement is obtained, therefore, the determination of the unknown DC is independent of the source. Our front panel control. The front panel differential voltmeter shown in figure 415 in view of the difference with the control terminal similar to the U with the different voltage in the null sense of the switch converts to the TVM mode of the operation varies the full scale of the null detector center of the range of the instrument with the differential mode of the range switch allow the selection of the desired input voltage range position of the read dial decimal point of the select for the voltage range with the null sense switch for the readout style provides visual reading out with the measured voltage instrument with the differential mode. So the input terminal input terminal ground terminal mode switch mechanical zero control meters power switch null sense switch range switch readout DIA's mode with the operation the two primary modes operation conventional transistorized voltmeter mode and the differential null mode of the modes are described in the next paragraph. The conventional transistor voltmeter mode instrument with the conventional transistor DC voltmeter circuit that's connected with the shown figure 416 and null detector drive the panel meter with the provide the full scale meter with the deflection of the full scale input of the positive negative voltage measurements are made with reversing the meter terminal with the context of the mode switch. Alright, this is a large AC differential voltmeter block diagram, functional block diagram. The figure 416 is the functional block diagram of the differential voltmeter circuitry made up of the reference supply or resistive divider, DC input divider, AC and null detector, and a meter. The circuitry is connected by various switching arrangements. You perform the desired AC, DC conventional differential voltmeter measurements. Placing the mode switch in figure 416, the AC position connected to the instrument circuitry is the eventual transistorized AC voltage scale input voltage input terminals instrument. The result of the voltage applied with the input with the null detector drive the front panel with the meter, then indicate with the measured AC voltage. Differential null mode. The instrument that you with the DC differential voltmeter, the mode null sense switch is in figure 416 place, and the respective positive negative DC desired full scale meter with the sensitive position in the mode of the operation. Null sense switch is suitable to require the value of determination full scale sensitive material meter. DC input voltage applied with the instrument that compared with the null detector. The resulting difference you would derive the meter with the meter terminals can be reversed throughout the contact with the mode through switch with the positive negative DC volt measurement. Alright, your transistor tester. Laboratory transistor testers use the experimental work of the test character of the transistor for maintenance of the repair. However, checking all the transistor parameters is not necessary. Check with the 2 of the 3 performance characteristics usually sufficient to determine whether the transistor needs to be replaced. 2 of the most important parameters of the transistor testing of the transistors are current gain beta or current collector leakage reverse current. 2 other system testers can be accomplished by electrode resistant diode measurement that you may want to review the Neets module of the introduction solid state device power supply for view of the transistors and continuation of section. Semiconductor test ANU SM206A is a rugged field type design field tester type to tester designed to test transistor semiconductor diodes. This will measure the beta transistor resistance by applying appearing to electrode reverse current of the transistor semiconductor code of the diode. Whether it was also measure the short open conditioning diode of the forward transducent with the field effect of the transistor with the condition of its own batteries. Alright, to ensure the accurate with the useful information for the game with the transistor tester, you should make the following preliminary check with the tester before testing transistor. Where the polarity switch in the opposition of the meter point should be exactly 0 with the required with volts and rotate with the 0 adjusting the up at the front of the meter with the full fill. This requirement to prevent the battery drain. Be sure to leave the polarity switch on the off position with the measurement that are not actually being made. Always check with the condition of the test battery to make the change. Check with the disconnect of the test set of the power cord with the polarity switch with the positive negative positive transition. Play with the function switch in the first battery and then the battery second. For the battery position for the meter point should be moved with the indicate with the red battery box. Beta measurements. If the transistor is to be tested, the circuit plug within the test jack will locate with the right hand side with the meter with the transistor test with the circuit less over the least of 300 ohms must exist between the emitter to the base and the collector to the base and the collector to the emitter. The accurate measurement of the initial setting of the blood test, the controls are measured with follow to set the function of the beta, set the polarity switch of the positive, negative, positive, depending on the type of the transistor. And under the test, set the range with the switch to times 10, the edge of the meter 0 with the meter indicator transistor detector. Disconnect the polarity switch of the remaining off of the transistor. Connect the disconnect from the test set shown with the positive, negative, positive step, but 2 above the beta reading is left and 10 perform the following steps. Reset the range switch times 1. Reset the meter 0 after connecting with the yellow test with the lead ammeter, the green lead with the base of the blue with the test leader with the collector with the plug with the test probe with the not showing the jack located with the lower right hand corner of the test tube. Test set. When testing ground equipment, they include and plug with a 115 volt line cord with the battery condition of the both reading and taking the multiplier reading it type with the range switch setting. For the transistor characteristic book provided with the test to determine the reading of the normal type of the transistor under the test. ICO, the adjust of the meter 0 with the 0 meter indicate the plug with the transistor to be tapped with the jack with the connect with the test lead with the device. Positive, negative. Switch corresponding to the type of the transistor on the type of the function of the ICO, in the range for the switch for the 0 times 1, 10, 1 and 10 as they specify the transistor data book allowable leakage, read the leakage of the bottom scale with multiply with the range figuring is required. Our electric code resistant measurement, the contact with the encircled probe with the tap of the lead with the transistor yellow lead with the image with the green with the lead with the base of the lead with the collector select the fixed switch to ohms emitter base position of the resistance of the between the emitter with the base electrode with the center scale with the mark with the ohms derive the resistance between the collector and the base of the collector and the emitter set the function of the ohm scale with the collector base and the ohm scale collector emitter respectively. These encircular electrodes resistant measurement they are used to correctly interpret the encircular measurement of the accuracy of the benefit times 110 range with the plus or negative 50% only with the emitter base load with is equal to greater than 300 ohms. Alright, diode measurement. The diode encircular with the quality measurement they're made with the connect with the green test lead with the cathode with the yellow test lead with the anode section phone with the diode in CKT or range switch over the time position ensure the meter has probably zeroed over the end of the scale of the meter reading the down for reverse polarity and with the meters regardless reads less than the mid scale of the diode under the test and either the open short related circuit impedance less than 25 ohms. Alright, resistance of the capacity inductance bridge. The capacity resistance capacity inductance can be made with the precise accuracy with the alternating current bridge of the bridge is coupled with the capacitor inductor resistor for a wide variety of the combination of the battery edge of the operator with the principle of the Wheatstone bridge is unknown the resistance balance against the unknown resistance after the bridge has been down with the unknown resistance of the calculated in terms of the known resistance universal impedance of the bridge of the model 250DE with shown figure 418 the use of the measure the resistance capacity inductance values also to make the measure of the special tests such as to determine the term ratio of the transformer, the capacitors, the quality tip of the instrument with the self-contained, except for the source of the line power with approximately 500 hour life expectancy has only the source of the 100 hertz of the bridge current with the sense of the bridge balance of the indicator adjusted source of the direct current with electrolytic capacitor resistance testing the bridge has also contained meter with a sustainable range of the current leakage of the electro capacitors. Alright, control figure 418 of the panel with the view with the 250D with the bridge switch with the dial connected with the dials control of the connection before the figure with the briefly discuss the switch and dials below. The function switch is selected with the type of the bridge circle the width of the measure resistance capacity inductance of the range switch select with the multiplier each with the function the LRC decade dial the decade stat the decade resistor of the main balance element of the bridge of the assisting dial after the bridge balances indicate the value of the inductance of the resistance and the capacity. The DQ is used to balance the phase of the capacity, the inductance of the bridge. The setting with the dial with the bridge with the indicate the value of the disposition factor or the storage factor. The G generation is which switch of the bridge generator detector connections to AC and DC internal external generator which also connects internal battery to the battery test circuit. The DET gain contains control of the adjusting sensitivity of the AC detector turns on the power to the generator. Alright, connections. The inductor resistor capacitor terminals 1, 2, and 3 are used to connect the unknown resistor inductor capacitor to the bridge. Resistor inductors connected between the terminals 1 and 2 connectors are connected between the terminals 2 and 3 with the external basis bias. The terminals normally connect with the shorting load where they allow the inserting the DC voltage current bypass capacitors and inductors extension of the DT of the BNC coaxial socket allow the external detector to be with the instrument connected to the bridge at all times. Extended DQ terminals normally connect with the short lug that allow the external rheostat to extend of the range of the DQ dial. Extended GEN terminals provide with the connection to the bridge with the external generator. The generator DET, the choice of the AC external generator position terminals connected with the isolation transformer. The ground external generator can be used while the generator DET switch for the DC extend GE position to terminals connected directly to the bridge. Alright, your battery. The 250DE bridge has a battery supply with consisting of the 1.5 DC volt DC batteries expected with a life of 500 hours. The battery power supply should be checked before each the operation of the DET game with control of the 1 set of the generated DC switch battery test of the meter deflects beyond the battery. Okay, market battery is good. Our resistor measurement. The resistor that usually measure the direct current of the maximum rack with the mouth 250G bridge with the with the measure resistance alternating current with external resistance compensation. Usually required only high resistant range of carrier should be avoided. The leakage across the resistor under the test installation resistant 109 ohm with the adequate most purpose will call for the measurement. Here with 1% of the shown the 10 mega ohms with the U of the following steps you will be able to measure the DC resistance only set of the DET deterrent game with the control the two functions switch to the R times 1 R times 2 so the LRC decade dials of 3000 connect the unknown resistor or inductor terminals 1 and 2 the generated data switch internal and intermediate DC adjust the rating switch of the medium detector reflection of the edge of the inductor resistor capacitor decade the null the term the detent gain control clockwise increase sensitivity necessary for the measure of the resistant product with the LRC dedicated dial setting time of the range and function switch settings. Alright, capacity measurement. Capacity is measured in terms of the two element equivalent circle that consists of the capacitor served with the resistor, the internal AC generated with the detector model with the 250 bridge with the unit between the 1 kilohertz. The frequency can be used with the external generated detector is required. D and Q range of the bridge with the extent of the external rheostat technique for the terminals to provide with the measure of the capacity with the product of the LRC dial setting with the range switch. View with the following switch you can make the same capacity measurements. Turn the DET det gain turn gain to control the 1 function of the CD1C switch to C D times 0 to 10 0 to 100 series. The LRC decade dials 3000 DQ dial to 0. Connect the unknown capacitor C to terminal 2 and 3 generation detector switch in INT 1 kilohertz. Place the adjust the range switch with minimum detector deflection. Adjust the LRC decade dials DQ dial alternatively minimum meter deflection. Turn the detent game the counterclockwise. Increase the sensitivity necessary. Measure the capacity of the product of the LRC decade dial setting. Measure the dissipation the factor of the product with the DQ setting in terms of the function and switching settings. Our inductance measurement. Inductance measurement the term of the two element equivalent circle to occur the inductance either circular parallels resist the internal AC generator detector module 250 dB bridge with the 2 with the 1 kilohertz frequency can be used but like capacity measure the external generator detector required the inductance may measure the AC DT should be reliable and the inductor core of the the current variation quantity of the measurement the DC effect can be made supplying the current of the unknown of the inductor to the external bias terminal following the same step of the making inductance measurements. Alright, so the detector gain control the 1 function, the L parallel with the Q is greater than 10, and the L series with the Q is less than 10, so the LRC decade dial with the 3000 DQ dial with the maximum, connect with the unknown indicator to the RL terminals 1 and 2, the generated detector switch will enter in INT to 1 kilohertz, adjust the range switch with the minimum detector deflection, RLC decade dial with the DQ L to a minimum meter deflection, turning the detector gain control clockwise. Increase sensitivity necessary measure the inductance product LRC decade dial to earn settings to range with the switch settings the measure storage factor reading directly the DQ dial with the inner scale with parallel and outer scale with the series inductance. And that was chapter 4, and then we'll come back and read the chapter 4 summary.